Alright, today Academic Daddy will be teaching you everything you need to know on Lewis structure. Uh, you need to know that Lewis structure is one of the three types of model. We have valence model, the molecular orbital model, and we have Lewis model. So it's one of the three types of model used to present the force of attraction or the number of electrons found between elements that make up a particular compound. And this structure tries to present it that for you to be able to balance the compound, or for compounds to come together, they attain stability, the octet rule, the rule of 8. They must have 8 electrons in each atomos shell. So let's consider examples we have here. And these are examples from the textbook. So the first knowledge you need to have is what we call how to identify the number of electrons in a compound. So for example, CS2 is carbon and sulfide. So when you have this, you know that in the outermost shell of carbon we have 4 electrons, the outermost shell of sulfur we have 6, but here sulfur is existing as S2, so that means 6 times 2, which gives me 4 plus 12, and that is 16. So there are total of 16 electrons in this atom, in this compound. 16 electrons in this compound. So if I know that, using Lewis structure now, the principle, the strategy, remember this is my personal trick. So you just need to know and observe everything I'm going to do today. You will see something different, or should I say more like a straight up. So this is carbon. I know that electronegativity increases down the across the period. So that is, so if I know that, and it increases down the group, so as I'm going towards the right, so if I know that carbon is less electronegative when compared to sulfur. Sulfur is number 16, while carbon is is having 6. So it's in group 4, while sulfur is in group 6. So if I know this, let me put carbon as the central atom because it's less electronegative. So then sulfur this way, sulfur this way. So now that I have this sulfur, I'll now ask myself, the first trick is to be able to identify the number of electrons. The first, identify the number of electrons. Now number 2 is to make a skeletal structure using make a skeletal structure by using the one with less that exhibits less electronegativity, placing it in the middle, placing it as the central atom. Now the minute you are through with this, you need to check how many bonds in this your skeletal structure, how many bonds are there. So identify or no, identify bond number, the number of bonds, bond number. So in this particular question, identify bond number. In this particular question, we have 1 2, we have 2 bonds, and 2 bonds. On each bond here I have 1 electron, 2 electron, 1 electron, 2 electrons. So if you have 2 bonds, it means 2 times 2 equals to 4. If you have 3 bonds, it means 3 times 2. If you have 20 bonds, it means 20 times 2. So in this case we have 4. Now the next thing to do, the fourth step is to subtract this number of electrons, or the bond electrons. Subtract bond electrons from total electrons in the compound, total electrons of the compound. So since I have 16 here, I'll do 16 minus 4. So if I do 16 minus 4, that is obeying this step. If I do 16 minus 4, we all know that it's going to give me 12. So if I have it, that means the total number of electrons that I will use to get my Lewis structure. So Total number of electrons I will use to get my Lewis structure is 12. So since I have that 12 now, I will now come here, which is the fifth step. The fifth step is to always start from the right, the terminal. You have C, central. This is the right terminal. This is the left terminal. So always start from the right terminal to disseminate this your remaining electron. So share the remaining electron first to the right terminal before the left terminal. So when you are done, if the electron finish, you try and check if it's balanced. If it's not balanced, you now start to do number 6. That is, you carry lone pairs. You carry lone pairs from the terminal. Now you need to know that lone pairs are pair of electron that is already balanced, like that is having 2. When you just have a single pair, you say it's a bond pair. So let's go back to this. Since we have 12 with this 16 minus 1, we got 12, and we say that that 12 is what is available to share. Let's start from the right terminal. I'll do 1 2 3 4 5 6. Then I carry on 7 8 9 10 11 12. So I've been able to exhaust that electron, the 12 electrons. So since I've exhausted these 12 electrons, but check, is carbon balanced? Carbon is still 1 2 3 4. It's not balanced. It's not balanced, but this one is balanced. 1 2 3 4 5 6 7 8. Sulfur is balanced. The same thing with the sulfur at the left terminal. So we'll now say step 6, carry lone pairs from the terminal. So whatever you do to this side, do it to this side. Carry lone pairs. This is a lone pair. Lone pair simply means that it's not supposed to participate in the bond, but because of this situation, we need to carry it. So lone pair is those ones that did not take part in the bonding, but this time we make the lone pair to take part. So carrying a lone pair simply means I'll come and carry this thing now. Carry this thing now. So that if I carry this lone pair, it's trial and error. If I carry it, I'll bring it down. Remember that this was like this initial. I have S. So if I carry this lone pair, it will come down here. If I carry this lone pair, it will come down here. Now notice that the minute I carry it, it will no longer be here. It will no longer be here. So that I will now have this, bond, 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 bond. So now that I know this, let's check if carbon is balanced now. 1 2 3 4 5 6 7 8. I told you that on each bond there exists an electron. There's an electron here. Electron. So how many bonds? 1 2 3 4. 4 times 6 8. So carbon is balanced. Let's check for sulfur. 1 2 3 4 5 6 7 8. Balanced. 1 2 3 4 5 6 7 8. Balanced. So this is the structure. This is our structure. So this is the answer. So look at the step. First, number of electrons, skeletal structure, identify bond number, subtract bond electrons from total electrons of the compound. Then should I say place the electrons on the right terminal before the left terminal. So let's take the second question. The second question is B. Okay, so we have hydrogen, we have carbon, and we have nitrogen, perchlorous nitride. Now if we have this, we know that using our principle, this is something as saying H, C, and N. Reason being that nitrogen is higher in group, it has more electronegativity than carbon. Then hydrogen itself has just uh, two bonds. It has just two bonds. It exists at the duplex structure, so it's always in a position where it will have just two electrons. So if I know this now, I will say how many electrons are in this compound. First of all, I know that this is going to be one electron, this is four, and this is five in the outermost shell. So this is the same thing as saying 5 plus 5, 10. Shebi 10. So since I get it, I'll now ask myself how many bonds exist here. 1, 2. So 2 bonds. That means 2 times 2, 4. So 10 minus 4 is going to be 6. 10 minus 4 is 6. So that remaining 6 now. So we subtract the number of electrons in the compound. We subtract the number of electrons in the bond, or the bond electrons, from the total number of electrons in the compound. So since we've done this now, we now have that this is going to be giving us just 6. So let's come and share that 6 electrons, so that I have, let me write this, HCN. I'll now have, so always start from the right. 1, 2, 3, 4, 5, 6. So 6 electrons. So if you check it, this is balanced. Oxygen is having one, hydrogen is having 1, 2, supposed to be 2. Then this one is having 1, 2, 3, 4. So it's only carbon that is not balanced, but nitrogen is balanced. So since carbon is not balanced, we'll come and say let's carry, and we've exhausted the electrons remaining. It's just 6. So once we've exhausted the electrons, let's carry this lone pair first and check if it will work. If it doesn't work, we'll carry another lone pair till it balance. So I have this. When this lone pair, you carry it, it will turn to a pi bond. So that I now have this as, it will turn to a sigma bond, not a pi bond. Sorry. But when it comes here, it makes it become a pi bond. Oh, I don't want to start going into hydrocarbon now. So let's check. This is now, carbon is now 1, 2, 3, 4, 5, 6. Still not balanced. It's still not balanced. So since it's not balanced, let's carry another lone pair, which is the one up. We'll carry this one. Then let's carry another one. So that if we carry it, it will now be HC. Then carry that lone pair, it turns to a sigma N. So if you check it, let's check if it's balanced. This is now 1, 2, 3, 4, 5, 6, 7, 8 for carbon is balanced. Then nitrogen 1, 2, 3, 4, 5, 6, 7, 8 is balanced. So hydrogen is 1, 2. So this is the structure, the Lewis structure of this. So this is the Lewis structure. So let's move to number 3 question. So number 3 question, we have, number C question, we have carbon, we have oxygen, we have Cl2. So going by that, I will now check how many electrons are in this compound. Carbon has 4 in the outermost shell, oxygen has 6, chlorine has 7, and here it's existing as a gas. So this is Cl2. So 7 times 2, this is 14 times also 14. This is, yes, okay, I'm correct. Are you kidding me? This is 14 plus 6, which is 20, plus 4, which is 24. So we have 24 electrons in this compound. So let's write it. Let's try to present it so that I now have that this will be, carbon is the least electronegative here. Then let me write oxygen one side by the right. So always, anywhere you see oxygen together with other elements in a compound, always try to separate oxygen, so that I have this way. Then I have chlorine, the first one, and I have the second one. So how many bonds exist here? I have 1, 2, 3 bonds. So since I have 3 bonds, it's the same thing as 3 times 2. 1 2 electrons, 1 2 electrons, 1 2 electrons. It's something as 3 times 2 6. So I'll do 24 minus 6, and 24 minus 6 will give me the same thing as saying remove this 6 here, so that I do 14 plus 4, which is 18. Now that 18 that you have, whenever you see oxygen, you're supposed to always start from where you have oxygen. But because the rule is start from the right, let's start from the right. So the 18 electrons, let's share it. I have 1 2 3 4 5 6 7 8 9 10 11. Sorry, you don't go to carbon, you start from the terminal. Anyone that is central, anytime you see carbon with any other element, assume it to be the central. So you don't go to it until you give electrons to the right terminal and the left terminal first. So I have 6 7 8 9 10 11 12 13 14 15 16 17 18. So we've been able to disseminate this electron. So now that we are through with disseminating it, you notice that chlorine, the two chlorines are balanced, but carbon is not balanced. It's having 1 2 3 4 5 6. Oxygen is balanced. It's having 2 1 2 3 4 5 6 7 8. So what I will do here is, since chlorine is balanced, carbon is not balanced, but oxygen is balanced. I told you, after disseminating the electrons that are remaining, you now come and say, since it is not balanced, carry a lone pair. So from this oxygen, I will carry this lone pair and put here, so that I will now have O, then that lone pair, then my C. Write every other thing to be the same. Let's check if it's balanced. So I have 1 2 sorry I have 1 2 3 4 5 6 7 8. Then for this particular chlorine, I have 1 2 3 4 5 6 7 8. For carbon, I have 1 2 3 4 5 6 7 8. For oxygen, I have 1 2 3 4 5 6 7 8. So it's balanced. Now let's go to the last one. The last one is the hydrocarbon, acetaldehyde, or you call it ethanol. Alright, to draw the Lewis structure of this, I have the electrons in the valence shell. Everything is giving me 18. Now if it's giving me 18, that means that I will now have this to be C. Always make sure that once you see hydrogen is not supposed to be in such a way that you do things like this. For example, you do H, because it's 3. This is wrong, because if you check it, this particular hydrogen in the middle now is having 1 2, and that is 1 2 3 4. Hydrogen cannot have up to 4 electrons. It exists as duplet. So this is going to be in such a way that hydrogen around this carbon, the 3 round it. Then I have the next C. Then I have the hydrogen round it, or okay, so round it. Then I have O, the last oxygen, that is the O. So when I check it, this is having 1 2 3 4 5 6. That is 6 is the same as 6 times 12. 6 times 2 is 12. So it's the same as 18 minus 12. So 18 minus 12 will give me 6. So let me start from the right hand side and then split it 1 2 3 4 5 6. So if you check it, I now have this particular carbon is having 1 2 3, is having 3 times 2 6. So it's remaining. So carry this. If I carry it, I now have that this is the sentence. So there you have it. So So this is the structure. We'll carry